Hello everyone. Today we will discuss about mechanical properties of solids, and the first topic is elasticity. You must have heard about the term elasticity, but when we speak about elasticity, what comes to your mind is the rubber band. But we'll study the technical aspect of elasticity, what it is, and sometimes your misconceptions will be changed. So elasticity is the property of a body by virtue of which it regains its original shape and size once the deforming force is removed. So you can say that you have a table. If you try to deform it, then you don't realize that was any momentary deformation in it. That means it has regained its original shape and size. And since it regains it very immediately, we can say that the table is more elastic than rubber band, right? So elasticity, it is the property of a substance by virtue of which it regains its original shape and size on removal of deforming force. So that means plasticity is opposite to it. So it's the property of a substance by virtue of which it does not regain its original shape and size on removal of the deforming force. Then when we are talking about deforming force, that means the concept of stress is also there. What is stress? We'll discuss here. So if we have a wire and we apply a deforming force here, what happens? The particles inside it start opposing their deformation and develop equal and opposite restoring force gradually. So this is the restoring force and this is the deforming force, and this is the area of cross section. So the restoring forces developed per unit area on application of deforming force is called as stress. So the restoring forces developed per unit area in a substance on applying deforming force. This is called as stress. So based on in what way the stress is applied, we have stress of many types, three types basically. So types of stress I'm just mentioning in short. So first is longitudinal stress. Longitudinal means force applied lengthwise, along length. Then we have normal stress. This is also called as hydraulic stress. So this is when the force is applied perpendicular to the surface from all sides on its volume. Third is tangential stress. This is also called as shearing stress. This is also called as shearing stress or shear stress. So when force is applied tangentially. So this is like wire case. So if we have a wire and we are applying the force like this, so this is longitudinal stress. We have a body and we are applying force from all direction like this. This is volume stress or normal stress or hydraulic stress. And if we have a body like this and we are applying force like this, then this is called as tangential stress. What is the formula for stress? So the formula, as the definition indicates, that formula is force upon area. So what will be the SI unit? This will be Newton per meter square or Pascal. So let's discuss about the next concept, that is strain. Whenever we are applying some force, there will be a change in the dimension of the body. So if we are applying a force longitudinally, there will be a change in length. So if the ratio of the change in dimension upon original dimension we talk about, then we talk about strain. So strain is nothing but it is the ratio of change in dimension to original dimension, right? For example, delta L upon L, delta V upon V, and so on, right? Then we will talk about Hooke's law on the next slide. Hooke's law. We have studied about Hooke's law in chapter 6 also when we studied about spring. So it says that within elastic limits means we'll study about the graph later on. Elastic limit means the limit up to which if we apply the deforming force and after, when we remove the deforming force after applying, the body regains its original shape and size completely. So within elastic limits, the stress is directly proportional to the strain. And this can be written as stress is proportional to strain. If we remove the proportionality sign, what will we get? Stress is equal to constant of proportionality into strain, where E is equal to constant of proportionality called as this is called as modulus of elasticity. And it depends on the material. It depends on the material. Now, on the basis of the Hooke's law, we can discuss the three types of modulus of elasticity. So from this equation, we can write E is equal to stress upon strain. So when we apply this Hooke's law, we have three types of modulus of elasticity. The very first is the Young's modulus. So Young's modulus is the ratio of longitudinal stress to longitudinal strain within elastic limits. So I'll write that within elastic limits, the ratio of longitudinal stress to longitudinal strain is called Young's modulus. So we can write the formula. This is denoted by Y. This is denoted by Y. So Y is longitudinal stress upon longitudinal strain. And if we draw the diagram, we can draw the diagram of the wire. So if this is the wire and we are applying a deforming force on it lengthwise. So if this is the original length, this is the deforming force, then if we consider that the change in length is this delta L and area of cross section of this wire is A, then we can write longitudinal stress as force upon area. We know that the restoring forces are developed equal to the deforming force, and longitudinal strain will be change in length upon original length. So this gives us FL upon A delta L, and if we are applying force by attaching some weight, then F can be written mg. So this is the formula. We have many numericals based on this formula. SI unit of Y is equal to same as that of elasticity, Newton per meter square or Pascal. Here also I can mention SI unit of elasticity, modulus of elasticity is Newton per meter square or Pascal. Why? Because the SI unit of strain has no units. Why? Because this is change in dimension to original dimension. As delta L upon L, meter upon meter, no unit. Similarly, delta V upon V, no unit. Right? So this was your Young's modulus. Let's discuss the second type of modulus of elasticity, and that is bulk modulus. Now bulk modulus is generally denoted by this. So within elastic limits, the ratio of normal stress to volume strain is called as bulk modulus. Normal stress to volume strain is called bulk modulus. So if we write this, the formula becomes normal stress upon volume strain. So here I am showing a body where pressure is applied from all the sides, that is the force per unit area. You can consider it to be kept inside a liquid. That's why another name hydraulic stress is given to normal stress. So if this pressure is applied, what happens? The volume of the body decreases by delta V. So this change in volume is delta V, and initially the volume was V. So you can write that normal stress is what? It is actually pressure, that is force upon area, and volume strain is delta V upon V. But if you look at this, if we increase the pressure, volume decreases, right? So we can write minus sign for this. So this becomes minus P upon minus P V upon delta V, right? So this is your formula for bulk modulus. If we say that delta P pressure is applied, then we can write delta P for this pressure or normal stress. We have one more term which is related to bulk modulus, compressibility. This is equal to reciprocal of bulk modulus, and SI unit of bulk modulus is again Newton per meter square or Pascal. Then we have the third modulus of elasticity. We'll take that on next slide. So the third modulus of elasticity is modulus of rigidity, or you can say the shear modulus. This is also called as shear modulus. So within elastic limits, the ratio of tangential stress to shear strain is called as shear modulus. I'll tell you what is shear strain. The ratio of tangential stress to shear strain is called shear modulus. This is actually related to the change in shape. So always a change in shape is involved in this modulus of rigidity. So if we talk about this case, if this body is fixed at the base and I am applying a tangential force like this, so what is happening, just observe. So initially the body was like this was vertical, and when tangential force is applied, this has deformed little bit, right? So this force is tangential, so if it is applied on the upper face, then this is a tangential force per unit area. This is the tangential stress, and what will be the strain? Strain will be that angle up to which it shifts. So if we draw the diagram, this is the body and a tangential force is applied like this. So what happens is that it is this position. So this is theta. If we consider this shifting is delta x, and this was this initial vertical height of the object. So this force is applied here. Area of the surface of this body was A. So modulus of rigidity is denoted by eta. So this is tangential stress upon shear strain, and tangential stress is force upon area. Shear strain is here theta. And for small angles, theta can be written as tan theta, and this can be written as perpendicular upon base. So the modulus of rigidity can be written as F upon A theta, and this can be written as F upon A, and this is delta x upon L. So this will be the formula. Now come to the SI unit of modulus of rigidity. It's again Newton per meter square or Pascal, right? So this was all about the types of modulus of elasticity. Now we can move on to the next topic that we'll study in the next video. That's all for now. Have a nice day.